So let's do a quick review of all the stuff scientific notation. Right away, why do we use it? We use it for very large and very small numbers so that we can compare them or combine them. So for example, the number of genes in our bodies, huge number, right? So we can rewrite that in scientific notation. The coronavirus, very small. We can write that in scientific notation. And we can even compare it with the flu virus, which is also very small. So we write them both in scientific notation. Still though, if you wanted to compare them, it's not too clear. So sometimes we have to rewrite something in a kind of scientific notation so that the exponents will match. So the coronavirus is actually a little bit bigger. Converting forms. When you go from standard to scientific, basically you got to slide the decimal to be after the first non-zero number, and then you count the number of places that it moves. That's going to be the exponent on the 10. If it's a big number, the exponent's going to have to be positive. If it's a small number, the exponent will be negative. So here's a big number. Here's a small number. Let's take a look. 73 quadrillion is going to be, slide the decimal over. Sorry, that's trillion. Is going to be 7.3 times 10 to the something. Now, how do I figure out that exponent? Since the decimal moved 13 places, and we know it's a big number, it's going to have a positive 13 exponent. The next one, 627 10 millionths, is going to be slid over. So it's after the 6. And you're going to have 6.27. And then how many places did I move that decimal? 8. And it's a small number, so it's 10 to the negative 8. So always take a look, is it a big number or is it a small number? When you're doing the reverse, going from scientific to standard, you're going to slide the decimal according to the exponent and fill in how many zeros you might need, okay, so that the decimal fits in the right spot. And remember, same thing, if it's a positive exponent, that means it's a big number. So you'll move the decimal to the right, and if it's a negative exponent, then you'll move the decimal to the left. So 4.93 times 10 to the negative 5 is a small number. 6.287 times 10 to the 8 is a big number. You can tell by the exponent. So that negative 5 basically says, let's slide the decimal 5 places to the left to get what this thing looks like as an actual number. And you're going to fill in the zeros to where that decimal goes. We also like to put a leading zero in front of that decimal, giving you the value in standard form. The 6.287, I said, is going to be enlarged by a factor of 10 to the 8, so that's actually 100 million. So the decimal is going to slide 8 places to the right, and you're going to fill in the necessary zeros there up until where the decimal is. So this is going to be a very large number. Hopefully not too bad. Just remember big and small. Now, sometimes we have to convert an exponent form that looks kind of like a scientific into scientific. And the deal here is that sometimes we're going to make the number bigger or smaller depending on where the decimal is. So, okay, 0.06287 is a small number. It's got a negative exponent also. But the main thing I need you to recognize is to be scientific, it's going to have the decimal in between the 6 and the 2. And so how do we do that? Well, we slide it to the right 2 spots. And that's going to make our number 2 digits or 2 decimal places bigger. And so our exponent is going to have to balance it out, becoming 2 places smaller. You subtract 2. Watch out when you're subtracting negatives. 41.3 times 10 to the 5 is a large number, but it's not in scientific form. I need the decimal to be moved after the 4, and so that's making the number smaller. So the exponent is going to have to become 1 decimal place bigger. 5 plus 1. And the last little thing we have to talk about is sometimes we have to make exponents match. As we saw with the viruses, sometimes we need to compare numbers, or when we do adding and subtracting, we're going to have to make exponents change to match. So the rule is, if the battery is low, sorry about that, if the exponent is going to be bigger, right, then you're going to have to slide the decimal left to compensate. And if the exponent gets smaller, we slide the decimal to the right to compensate. So 9.7 times 10 to the negative 10. Okay, this is in scientific notation, but maybe I need to write it as something times 10 to the 8. So that would be making the exponent 2 digits bigger. So the number in front is going to have to get 2 digits smaller, 2 decimal places. And the 8.24 times 10 to the negative 1, which isn't in scientific form, and maybe I got to write it as something times 10 to the negative 3. So that exponent's going to have to become smaller. So I slide the decimal, the number of places. The exponent has to get 2 places bigger, so I got to make the digit in front, the coefficient, 2 decimal places smaller. And in the next one, I made the exponent 2 decimal places smaller. And so I got to move the decimal to become 2 decimal places bigger. That's all we have for today. So hopefully you'll remember this. You can refer back to the video as many times as you need.